Hi, today we're talking about chemistry. What do we mean when we say chemistry? Because this is not the chemistry that they say when they're talking about romance. This is chemistry in science. We're actually going to talk about what we mean when we say science in general, or what is the scientific method. We're going to talk about that, but we're also going to elaborate a little bit about some of the terms that are common in chemistry. So that is what I'm going to talk about today, and this is going to be chapter one. So, in the first part of chapter one, we're going to talk about chemistry and scientific method. So, what is chemistry? So, when we talk about chemistry, I want you to remember three things: matter or matter, change, and energy. What does that mean? Chemistry is the study of matter, and matter is just stuff, things that we see around us and inside of us, right? Everything that is matter. So it's the study of matter, the change that the matter goes through, and the energy that is either released or absorbed when that change occurs. Three very important things when we're talking about chemistry: the matter, which is stuff, everything; the change, that is where we have chemical reactions and things like that; and then the energy. So a chemical reaction is either going to require energy or give out energy. That is chemistry in a nutshell. So the study of matter, its chemical and physical properties. So this is the properties of matter, and then the changes of matter, so the chemical and physical changes that the matter undergoes through, and the energy changes that accompany the processes, right? So what we're gonna do today is look at a few of these terms and see what they mean. But before we do that, let's look at the scientific method. What do we mean when we say science? So you've heard about it, right? Somebody is like, oh, what does the science say about this? Or according to scientific reports or scientific studies, so and so it has been found to be so and so. So science is, and I want to emphasize this, right? Science is not the knowledge. Science is the process that we use to get to the knowledge. All right. So when you hear that, for example, science used to say that uh, information is so and so, and then you realize that science has changed its stance, it's not because science is wrong, because science is not the information itself. Science is the methodology we use to get to the reality or the highest certainty of what's happening in nature, or to solve problems that we have on a day-to-day basis. So science is not the knowledge, it is the process we use to get to the knowledge. And that knowledge might be wrong, but what are we going to use to figure out that it's wrong? We use the scientific process. All right, I want to emphasize that the science is a process. And this process, the beauty of it is, it has a built-in mechanism to correct errors, right? So even if it's wrong, it has a built-in mechanism to later correct itself. And another beauty of it is it's not just one scientist, it's a network of different scientists that are working independently, so that it's not just one scientist that made an error. We gotta make sure that whatever a scientist has found, it's collaborated and confirmed by other independent scientists as well. So this is a scientific process. It has been used to discover medicine, to discover a lot of new ways in agriculture. So it's responsible for our civilization. It's responsible for the discovery of whatever device you're using to watch this. The scientific method is a very robust process. So it uses steps that make sure that you're not making errors. Okay, so this is from the book where this is how it goes. This is how the scientific method goes. You observe a phenomenon, right? You observe a phenomenon. You question why or how it's happening. Then you propose a hypothesis. This is a potential answer of what's happening. And then you conduct experiments, right? You design and conduct experiments to test your hypothesis. And then you're going to analyze your data and your results from your experiments. And then from there, you're going to see like, okay, did we confirm our hypothesis? Yes. If you confirmed our hypothesis, you're going to formulate a theory based on hypothesis. If you don't confirm your hypothesis, you like, okay, something else is happening here. You come up with a new hypothesis, and then what do? You do new experiments that are going to test more to confirm whatever new thing that you came up with. So this is where the scientific method differs from many other methods, because it's circular, right? It makes sure that we keep repeating until we get to the bottom of whatever it is we are studying, right? So it's usually most of the time shown as a circle like this because it's a cycle, right? You question something, you hypothesize, you test, you conclude, and then after you conclude, you decide what happens. And most of the time, you're going to redo the experiments or come up with new experiments, come up with new observations, and so on and so forth, right? So the scientific method is a cycle, and again, it is a tool. Once you conduct so many experiments and they are independently corroborated with other scientists, and then you are able to publish them so that your peers can scrutinize them to make sure that you didn't make any errors. When they do that, then you come up with what we call a theory, right? This is where a lot of people actually get this wrong. They think that a theory is a theory in common language. In common language, whenever you say a theory, you are really talking about a guess, which is a hypothesis. But a theory in scientific methods, it is one of the highest levels of uncertainty that you get to after you have extensively studied and reviewed material and had other people study them independently and things like that. So a theory is a very high level of evidence. So we have, for example, the theory of gravity, the germ theory, atomic theory, evolution theory. You have different theories that we know they work. We've done them in the lab. Other people have done them in the lab. So a theory is not really a theory like we understand it. A theory is a high level of certainty, right? If you keep doing more experiments, something can go from a theory to a law. So some of the mathematical equations are laws now, and now we've gone from saying the theory of gravity to the law of gravity. All right, so this is the scientific method, right? Everything that makes it down here, right? Everything that makes it down here is robust and comes from like a lot of experimentation. A lot of it takes decades to get here. And most of the things, most of the science again happens in this cycle like this. But another thing, I mean, I could talk about this for hours and hours. I'm a scientist, so on a regular or day-to-day basis, this is my life basically. But what I would say is that a lot of drugs, for example, this is a reason why we get better drugs, for example, right? You have like diabetes drugs or heart attack drugs and things like that, but they get better each year or each 3 years because we don't stop. We don't find a drug that works and then we stop. We keep reiterating and coming up with new information and testing them. So this works in many, many fields, including social field as well. Studying population, studying psychology, studying how people work, how the brain work. You can use a scientific method to even, I don't know, if you're shopping and you're trying to find the best sweater to buy, you can use the scientific method because the scientific method again is a robust way to get to the truth. All right. So let's go back to chemistry. And if you remember, chemistry, we said, is a science that studies matter, the characteristics of matter, the changes that they go through, and the energy that is involved. The energy that is involved in the changes. That's the three things. So let's start by the first thing, which is classification of matter. How do we classify matter? You classify matter by its properties, right? The properties are the characteristics that we use to characterize or categorize matter. So a property, for example, can be by state, right? You can categorize things by state. Well, states of matter, right? You've heard of states of matter: solid, liquid, gas. We have more than that, but the three main ones are the ones that we're going to focus on today, right? So when you have matter, it can be solids, liquid, or gas, right? But you can also categorize matter by composition, by what they are made of, what are the things are made of, and what are the categories. You either have a pure substance or a mixture, a pure substance or a mixture. All right, a pure substance or a mixture. So you might have a pure substance or you might have a mixture. And a mixture may be homogeneous or heterogeneous, and a pure substance may be an element or a compound. So these are the characteristics of matter, and we're going to get back to them in a minute. But before that, let's go from characteristics of matter and then go to the changes in matter, right? Remember, that's another big aspect of chemistry is change. Change can be physical or chemical. It's very important to know chemical change, physical change, or chemical property and physical property. So what is a physical property? A physical property is a property that is observed without changing the composition or identity of a substance, right? Something that you can observe without changing the composition or identity of a substance. And physical change is something, it's a change that occurs without changing the composition or nature of that substance, right? So, for example, the melting of an ice cube, right? An ice cube goes from solid to liquid, but it is still water. So, that is a physical change. That is a physical change. But when, for example, you take gasoline, for example, and you burn it, and it turns into CO2. So you're changing the nature. If you change the nature, it's no longer a physical change, it's a chemical change, right? So, for example, magnetism is a physical property because, again, magnetism doesn't change the nature or the chemistry or of the substance, right? But chemical change is going to involve the conversion of the substances, the conversion of the nature of the substances, right? For example, here you take hydrogen plus oxygen gives you water. This is a chemical change, right? Hydrogen and oxygen have been converted into water. These are all different things. This is a chemical change. And looking at properties, chemical properties, this is a property that results in a change in composition, all right? So let's look at an example. For example, color. What do you think? Is color a chemical or physical property? Well, color color is physical property because it doesn't involve the change in nature. It doesn't involve the change in nature of something. But look at this. Flammability. How flammable something is. Does it depend on its chemistry? Yes, right? You can't change something's flammability without changing its chemical property. What about hardness? Can you change how hard something is without changing its nature? Yes, we can, right? We can freeze water, but it will still be water. So the hardness is a physical property. Odor and taste is a little different. It's a little tricky, but most of the time, when something changes its odor or taste, it's through a chemical reaction, right? Milk that has gone bad, it has transformed into another chemical and it tastes gross, right? It has undergone a chemical reaction, right? So something that changes an odor or a taste is a chemical property. Let's look at chemical changes. Boiling water to become steam. Is it a chemical change or physical change? What do you think? It's a physical change, right? What about when butter turns rancid? This is a chemical change. What if we burn wood? Burning is a chemical transformation because you have wood from the beginning and at the end you have ashes. This is a different chemical, it's a different nature. This is a chemical change. What about mountain snow melting in spring? Physical change. Decay of leaves in the winter. When leaves decay in the winter, they're not leaves anymore, right? They turn into something else. This is a chemical change. So this is how you can tell whether something is a chemical change or physical change, and we need to be able to tell the difference. But some properties, right? Some properties, going back to the properties, can be intensive versus extensive. We need to know the difference between the two. What's the difference between intensive and extensive properties? Well, it is all in the amount or quantity. So if you increase the quantity of something, does that property change? Right? So if you have a little bit of orange juice in a cup and you add more orange juice to fill it, the little bit of orange juice is yellow and the lot of orange juice is still yellow. So color doesn't change as you increase the quantity. That is intensive property. But look at this. What about the volume? That little bit of orange juice, its volume is small. When you add more, the volume increases. So when you increase the quantity, the volume increases or the mass increases. So volume and mass are extensive properties or properties that depend on the quantity of the substance. So throughout our semester, we're going to be looking at a lot of properties of matter. And every now and then I'm going to ask you, is this an intensive or extensive property? And you're going to look at, does this change when you increase this or does it stay the same? Intensive versus extensive. But let's look at let's go back to our classification of matter. Again, matter can be pure substance or a mixture. And a mixture can be homogeneous or heterogeneous. So let's look at first a pure substance. A pure substance can be an element or compound. What is an element? An element is a pure substance that cannot be changed into a simpler form of matter. What does that mean? It means that this is just the most fundamental thing that we have. If you take an iron bar and you break it, you break it, you break it all the way down, you're going to get to a point where you only have one iron atom. That is the element of atoms, right? And these elements, by the way, are the ones where we see on the periodic table of elements, right? This is the periodic table. So you have sodium here, magnesium, potassium, calcium. This is the periodic table of elements. So a pure substance can be an element, which is just going to be one atom. But sometimes elements will be. So you're going to have an element of like iron bar is this, right? This is an element of iron. But if you have an element of oxygen, oxygen doesn't like to be by itself in nature. So it's going to be O2. This is still an element of oxygen. So these are elements, pure substances made of one atom or one type of atom. These are elements. A compound, on the other hand, is a pure substance made of two or more elements. So a compound is a combination of elements, right? So H2O, for example, is, well, it's a compound. It's a combination of hydrogen and oxygen. Or NaCl is a compound. It's a combination of sodium and chlorine, right? Those are pure substances. Then we have mixtures. So a mixture, again, is going to be a combination of any of the two. So a mixture is a combination of two or more pure substances, right? So it can be water and salt. It can be coffee, for example. Your coffee is a mixture of a bunch of things, right? Mainly water and caffeine, but also sometimes you have sugar, and some people add other things like caramel and macchiato. I don't know what macchiato is, but it's going to be a mixture, right? But in a mixture, you have homogeneous and heterogeneous. Homogeneous mixture, right, is a uniform mixture where you can't really tell which one is which. So, for example, coffee has a lot of things mixed in. You can't tell and be like, oh, this is where caffeine is, or this is where sugar is. It's a complete uniform mixture. It's called a homogeneous mixture. A heterogeneous mixture is the opposite, right? It's a non-uniform composition. So if you take water and emission of water and oil, you're gonna look at it and you're gonna be like, oh, I see where water is, I see where oil is. So oil and water, or salt and pepper, you're gonna be able to tell which one is which, right? So this is a heterogeneous mixture. So just to recap again, you have matter, and matter can be a pure substance or an element, a pure substance or a mixture. And a pure substance can be an element, which is one type of atom, or a compound, which is two or more types of atoms combined together. And a mixture can be homogeneous or heterogeneous, right? This is how we classify matter. Now, another one that kind of confuse people, but that's okay. You don't have to get confused. So we've seen atoms and elements, right? These are the ones on the periodic table. Atoms are kind of like the elements, except when some elements like O2 have two atoms, right? But you have atoms and elements, and then we already looked at compounds, which is, so I'm just gonna give you examples for each. So atoms, let's say, something like sodium, like just from the periodic table. Elements is atoms, but some of them they come in pairs, right? Sodium is also an element. So this is an example of an element. A compound is an example is like H2O, right? It's a combination of two or more atoms. And then a mixture is a mixture of any of these. So it can be like NaCl plus H2O. This is salt in water. This is a mixture. All right? This is good. This is a mixture. One that I want you to know about as well is called a molecule. A molecule is a combination of any two atoms. Combination of any two atoms. The reason why I'm emphasizing this is because look at this. Elements have two atoms here. Compounds also have two atoms here. So a molecule can be an element or a compound because it doesn't care about atoms. And that sometimes confuses people. So I want you to get this. I want you to remember that. Let me see how I'm going to do this. There you go. Very good. Okay. So let's say we have atoms. For atoms, you just have these from the periodic table, single, no pairs, nothing. All right. For molecules, no, for elements, let's say elements. Elements, it's atoms from the periodic table, but some of them come in pairs, right? A molecule is any combination of the two. A compound is a combination of two different atoms, right? Combination of two different atoms. And then a mixture is a mixture of any of these four. Any of two or more of these four, right? So atoms can be again anything on the periodic table, oxygen, sodium, but elements is where you have atoms, but some atoms, when they become elements, they show up as pairs because that's how they like to show up in nature. But they are still pairs of the same kind. If they are pairs of a different kind, then they become compounds. Different atoms. Compounds, right? And then a mixture is going to be a mixture of any of the two above. A molecule is a combination of any two atoms, right? So, combination of any two atoms. What does that mean? It means that a molecule can be an element, right? It can be an element. For example, oxygen. I can't see my cursor. There you go. That's better. Oxygen, or it can also be a compound, H2O. So this is the confusion. A molecule is just a combination of any two or more atoms. So it can be the same atom, which makes it an element, or two or more different atoms, which makes it a compound. Right? So don't get confused by this. It's just different ways that we call things. Another one, I got this from the internet, but it shows you how elements, if they are atoms, they can be single atoms, but they can also be molecule if they come in pairs. This is elements. Compounds can be molecules, right, when they come together, or can be ions, and we're going to talk about that as well. But compounds is a combination of any two atoms, right? So I think that's what I have say today, but after this video, you should be able to tell me, right? You should be able to tell me what chemistry is, different things that define chemistry, right? Like matter and change and energy. But also, you should be able to classify matter by state or by composition, meaning that, okay, you have pure substances, you have mixtures, and in pure substances, you have elements, compounds. No, you have elements, you have compounds, you have molecules, and in mixtures, you have homogeneous and heterogeneous mixtures. So you should be able to tell me all of that. And when it comes to change, you should be able to tell me what are the physical and chemical properties, and then what are the physical and chemical changes. And you should be able to, if I give you any uh, event or any reaction, to tell me if it's a chemical change or a physical change, or if I give you any compound or anything, any chemical, you should be able to tell me whether it is a pure substance or a mixture. And if it's a pure substance, you should be able to tell me whether it's an element or a compound. For example, if I tell you like a cup of water, what's in here? Is it a mixture or a pure substance? It's a pure substance. And then is it an element or a compound? It's a compound because water is H2O. It's made by a combination of two atoms. All right. So you should be able to tell me that with anything that I give you that you haven't seen before. But other than that, we're done for now, and we'll talk about more chemistry next time. Bye bye.